Hello students, in this session let us discuss about Internet Protocol. The content overview proceeds with Internet Protocol address, types of Internet Protocol, class ranges of Internet Protocol, IPv4, IPv6 and differences between IPv4 and IPv6. Internet Protocol address. Every machine on network has a unique identifier. Just as you would address a letter to send in the mail, computers use the unique identifier to send data to specific computers on a network. Most networks today, including all computers on the internet, use the TCP/IP protocol as a standard for communication on the network. So, in the TCP/IP protocol, the unique identifier for a computer is called an IP address. Computers and internet communicate with each other with wired and wireless technology. Suppose if we want to download a file from the internet or upload a file to the internet, then IP plays a very important role. IP stands for Internet Protocol Address. IP addresses are unique addresses which are assigned in order to identify a computer or a device on the network. So it is a 32-bit logical address, and every device should have an IP address for the purpose of communication. IP addresses are 32-bit binary numbers which are divided into 4 octets, and each octet represents an 8-bit binary number. So 8 into 4 gives you 32, and that is how the IP addresses are 32-bit binary numbers. ICANN, Internet Corporation for Assigned Name and Numbers, are responsible for assigning the addresses. There are two types of Internet Protocol, Internet Protocol version 4 and Internet Protocol version 6. Let us discuss about IPv4, Internet Protocol version 4 in detail. IPv4 is the fourth version of the Internet Protocol and are the most widely used protocol. They are also considered as core protocol that routes most of the Internet traffic, which was developed by ARPANET in the year 1983. Addressing has become the critical component in the field of Internet. All host computers must use a uniform addressing scheme. So, IPv4 uses a 32-bit address scheme allowing to store 2 to the power of 32 address, which is more than 4 billion addresses. So below is an example of an IP address which stores the IP address in 4 octets with 8 bits in it. So each 8-bit binary numbers in an octet represents the decimal number. 10101111 represents the decimal number 195, whereas 0001010 represents 18, and so on. So this is how an IP address is represented in IPv4. Each of the 4 bytes is represented by a number from 0 to 255, which are separated by dots. This representation is referred as dotted decimal notation of the IP address. The IP addresses are again divided into two parts, that is the network ID and the host ID. Let us discuss about the features of IPv4. IPv4 is a connectionless protocol. When I tell connectionless protocol, the connection need not be established or terminated. Packets travel in all the directions from the sender to the receiver, and also operates on best effort delivery model. It allows to create a virtual communication over the devices on the network, and it is easy to remember the addresses, and it requires very less memory, and it already supports millions of devices on the network, and it also offers rich set of video libraries. So next we will discuss about classes of IP address. The IP addresses are broadly classified into 5 classes. They are Class A, Class B, Class C, Class D, and Class E. Each class allows for a range of valid IP addresses as shown in the figure, and each classes are divided into network ID and the host ID. Network ID identifies the physical network to which the host is attached, whereas the host ID identifies a specific computer on the network. So the ranges of a class A is from 0 to 127. The For Class B, it ranges from 128 to 191, and for Class C, the range is from 192 to 223, and for Class D, the ranges are from 224 to 239, and finally the Class E ranges from 240 to 255. So we'll be discussing in detail about the various classes of IP address in the next slide. Class A ranges from 0000 to 127, 255, 255, 255. Class A address has 7 bits for network ID and 24 bits for host ID, which allows up to 127 networks and about 16 million hosts per network. The higher order bit in Class A is always set to 0. Class A is used by organizations requiring very large size network like NASA and Pentagon. All zeros and ones in the network ID are dedicated for special IP address. The special IP addresses are few address spaces which cannot be used on the internet. So the total number of IP address in the class A can be represented as shown. So 0000 is a special IP address which is assigned to default network address and it cannot be used by the host. And 127, 255, 255, 255 is a special IP address which is a loopback address used to test the networking applications. Class B ranges from 128,000 to 191, 255, 255 and 255. Class B addresses has 14 bits for the network ID and 16 bits for the host ID, allowing up to 16,384 networks and about 64,000 a host per network. The two higher order bits in Class B is always set to 1 and 0. So Class B is used for organizations requiring medium-sized networks like IRCTC, railways, banking, etc. There are no special IP addresses in Class B. All the IP addresses are usable. Class C ranges from 192,000 to 223, 255, 255, 255. Class C addresses have 21 bits for network ID and 8 bits for host ID, and it is allowing up to 122 million networks and about 254 hosts per network. The 3-order higher bit in Class C is always set to 110. So Class C is used by organizations requiring small to medium-sized networks, for example, small universities, engineering colleges, small offices, etc. Class D ranges from 224,000 to 239, 255, 255, 255. The Class D was created to enable multicasting in an IP address. Multicasting allows a single packet to be transmitted to multiple destinations in a single send operation. The 4 higher order bits in Class D is always set to 1110. So since Class D is reserved for multicasting, there is no need to extract host address from the IP address. This is because data is not destined for a particular host. In Class E, the IP address ranges from 240,000 to 255, 255, 255, 255. The Class E is not divided into network ID and host ID. It is an experimental address that is reserved for future use. And the IETF, Internet Engineering Task Force, has been reserved these addresses for its own research. The 4 higher order bits in Class E addresses are always set to 1, 1, 1 and 1. So 255, 255, 255, 255 IP address is assigned to the broadcast address and it cannot be assigned to the host. Special IP addresses. There are few reserved IPv4 address spaces which cannot be used on the internet. These addresses serve special purpose and it cannot be routed outside the local area network. They are IP, private IP address, network IP address, loopback IP addresses, multicast IP addresses and broadcast IP address. Coming to private IP address, it can be used within a network, campus, home or small business and are private to it. These addresses cannot be routed on the internet, so the packets containing these private addresses are dropped by the routers. Network IP address 0000 is a default network address that cannot be assigned to the host. Loopback IP addresses 127.0.0.0 to 127.255 so on is used to test the network applications. This loopback IP address is managed entirely by and within the operating system. When you want to check the network connection, you try to send mail to your own mail and just see whether you reach the message or mail which you have sent. So it is entirely within the operating system. So when a process creates a packet with destination address as loopback address, the operating system loops it back to itself without having any interference of NIC. Multiclassed IP addresses. So 224 to 239 is also called as host group address where the source can send to a group of IP devices. There they cannot be used as the destination. Broadcast IP addresses 255, 255, 255, 255. Packets sent to a broadcast address is received by all network attached hosts rather than the specific host. IP datagram. TCP/IP uses the name IP datagram to refer a packet. The format of data that can be recognized by IP is also called as an IP datagram, or in short, small packets are called as datagram. When data is sent over the network, it needs source and destination details to reach the destination. So the IP datagram is divided into two components, the header and the data, which has to be transmitted over the network. So the fields in the datagram, except the data, have specific rules to be performed in the transmission of data. So the header contains information essentials to routing and delivery. So the header is going to have 20 to 60 bytes of data, where 20 is minimum and 60 is maximum. And the whole IP datagram can be of 20 to 65,536 bytes. This is the IPv4 header format. As we know, the header will have essential informations of routing and delivery. The IP header format is going to have various details about it. First, let us start with version. Version number is the number of the internet protocol which we are using. Since we are using IPv4, its binary number is 0100. Next comes the IHL. IHL is nothing but the internet header length, which is the length of the entire IP packet. Types of service. There are two types of services provided, DSCP and ECN, where ECN carries the information about the congestion seen in the route. Next is the total length, which is going to give the entire length of the IP packet, which includes the IP header and IP payload. Identification gives the information about whether it is an original packet or it is a fragmented packet. The flags of IPv4 header format gives the information whether the packet can be fragmented or not depending upon the size of the packet. Fragment offset. It tells the exact position of the fragment in the original IP packet. Time to live. To avoid looping in the network, every packet is sent with time to live value set, which tells the network how many routers the particular packet can cross. If at each hop, the value is decremented by 1, and when the value reaches 0, the packet is discarded. Next is the protocol, which tells the network layer at the destination host to which protocol this particular packet belongs to. That is the next level protocol. So depending upon the number, we can identify the protocols. It is 1 for ICMP, 6 for TCP, and 17 for UDP. Next comes the header checksum. This field is used to keep checksum value of the entire header, which is then used to check if the packet is received error-free. Next is source address and destination address, which are 32-bit addresses of the sender and receiver of the packet. Options. This is an optional field which is used if the value of the header length is greater than 5. These options may contain values such as security, root record, and timestamp, etc. But there are some limitations of IPv4. The first one is the limited address space. Since there are large number of users who use internet, 4 billion IP addresses were not enough. IPv4 was running out of unique address space, leading to rapid depletion of public addresses. Next is the flat routing infrastructure. Here, individual address prefixes were assigned and each address prefix became a new route in the routing table. Today, it is a mixture of flat routing infrastructure and hierarchical routing infrastructure. Next is the configuration. IPv4 must be configured either manually or through dynamic host configuration protocol. Next is the security. Security of IPv4 is specified by the use of Internet Protocol security, but the security has to be built in, which is even more important today. Last is the limited quality of service. The services also are very limited. All of these issues made the Internet Engineering Task Force to begin the development and replacement of protocol for IPv4. And there came the IPv6. IPv6, the Internet Protocol version 6, had improved traffic routing and better security. IPv6 is the recent and next generation IP address. Internet Engineering Task Force started working and developed a protocol IPv6 which replaced IPv4. IPv6 was 128-bit hexadecimal address space and approximately it supported a total of 2 to the power of 128 addresses. The 128 bits were divided into 8 blocks of 4 hexadecimal digits represented by colon hexadecimal notation. Below is an example of IPv6 address format. Here A to F is used for 10 to 15. Here are some features of IPv6. The IPv6 provides a larger address space than IPv4. Since IPv4 has only 32-bit address space, but IPv6 has 128-bit address space. This large address space allows a better and an efficient route management. Next is the auto configuration, which allows the devices to automatically configure their IP address and other parameters without the need for a server. And it also consists of simplified headers, which leads to faster routing, and it has a better built-in security for the applications, which is provided by the network layer, which adds the Internet Protocol security encryption to all the nodes. There is a support for real-time audio and video. Administration is easier and it also provides better multicast and anycast abilities. Multicast, as you know, it allows a single packet to be transmitted to multiple destinations in a single send operation, and it also supports unicast and broadcast. This is IPv6 header format. IPv6 has much simpler packet header compared with IPv4, which includes the informations of forwarding the IP datagram. IPv6 header has one fixed header and it sometimes has 0 or more optional headers. All the necessary informations which are required by a router is kept in the fixed header. IPv6 is very similar to that of IPv4. Here also we have certain fields which has to be discussed. First comes the version. Version is 4 bits. It represents the version of Internet Protocol. Since it is IPv6, its binary equivalent is 0110. Next is the traffic class, which is 8 bits. These 8 bits are divided into 2 parts as most significant bit and least significant bit. So the least significant bit is used for explicit congestion notification, which gives the congestion of packets on the traffic. Next is the flow label, which is 20 bits. This label is used to maintain the sequential flow of the packets belonging to a communication. This field usually helps to avoid reordering of data packets. Next is the payload length, which is 16 bits. The payload is composed of the extension headers, which gives the total length of the data which is being carried. Next, header. It is 8 bits. This field is used to indicate either the type of extension header or if the extension header is present or not. So it acts as a pointer here. So next comes the hop limit, which is very similar to IPv4 header format, which is 8-bit, and this field is used to stop the packet to loop in the network infinitely. Next is the source address, which is 128-bit, and destination address is also 128 bits. So far we have discussed what is IPv4 and IPv6 header formats and its features. Now let us discuss some of the differences between IPv4 and IPv6. Coming to IPv4, it is 32-bit length and IPv6 is 128-bit length. In IPv4, the fragmentation is done by the sender and the forwarding routers, whereas in IPv6, fragmentation is done only by the sender. And in IPv4, there are no packet flow identification, whereas in IPv6, with the help of flow label field, packet flow identification is available. In IPv4, there is checksum field in the header, whereas in IPv6, no checksum field in the header. In IPv4, option fields are available in the header, whereas in IPv6, there is no option field but extension headers are available. IPv4 has ARP, Address Resolution Protocol, which translates or maps IPv4 addresses to MAC addresses. Whereas in IPv6, ARP is replaced by Neighbor Discovery Protocol. IPv4 has broadcast message, whereas IPv6 does not have broadcast messages. IPv4 has static IP addresses or DHCP, Dynamic Host Configuration Protocol, which is required to configure the IP addresses, whereas in IPv6, auto configuration of addresses is also available. Not only that, the security feature is good in IPv6 when compared to that of IPv4. So these are the differences. I think we have discussed Internet Protocol in detail, starting from Internet Protocol, its types, classes of IP addresses, header formats of Internet Protocol, version 4 and version 6, and its differences. Thank you.